So, hi everybody. Welcome to part three in the series of the simplistic servers or reference implementation here at Wireless Car. I'm Thomas Rea. I'm a solution architect and cloud architect here. And our reference implementation is to showcase some of the patterns that we talk a lot about and implement multi-tenancy, serverless, service isolation, account isolation, usage of IAM, cloud formation, continuous deployment, etc., etc. In the previous films I've made on this, we talked about multi-tenancy, how we define multi-tenancy, uh, how we secure the data in a multi-tenant solution, how we secure the runtime, how we provision tenants, how we isolate services, and how we use accounts, AWS accounts, to help with that isolation. This session is on continuous deployment, testing, and monitoring of the reference implementation. Just to before we go into that, let's look at a few takeaways from the previous sessions. So if we start from the data, we say that we define the IAM policies as close to the data as possible in order to protect it as well as possible. It's all about getting the IAM permission tight and possible as possible, and making manage policies that we use to access so that the roles don't define their own policies, but we use managed policies. Then protecting the runtime is really important. It's also about IAM, but even there we want to add a little bit more icing on the cake. So we use function shield from PureSec in order to trace traffic that goes out of our lambdas when they're not deployed in VPCs, so that we get the equivalent of flow logs, so we know what the lambda is talking to and that we can make alarms on that. And then on the API level, we use custom authorizers that validate our JWT tokens, and we use Cognito to provision those users and tokens. And when it comes to the service isolation, we use AWS to isolate our services. So we provision one account per service. This allows us to minimize the access to the service just to the team that actually manages that service, so we don't have hundreds of developers accessing the same accounts. It's nice for GDPR, and we also have high auditability on our accounts. So we've ensured that our administration of the application in runtime is secure and good, and that the application in itself is secure. Now we need to take a look at our continuous deployment process in order to make sure that that one is secure as well. We have a dashboard in Overseer for the service. We've split up the service into life cycles that we want to manage separately, and it looks a little bit like this, and it kind of falls back to the way we draw our architecture, with monitoring bots, the API layer, the implementing components, and the data layer. So we have all those build pipes that use Sonic, which is our pipe runner, to do the continuous deployment. And we go from Git into the accounts with those different life cycles. So let's take a look at the life cycle of one of those Git repositories. And it's important to understand that we trust Git. If you are allowed to merge a pull request or to push to the main to the master branch of a Git repository, then you will get your code change into production one way or another. So it's all about setting up who gets to push to Git. That's one of the basic fundamental trusts that we need to ensure. Then the build pipe produces artifacts. Those artifacts go into different buckets and databases, and those need to be secure, and that is what Delivery Engine does for us to ensure that. And then it's important that the deployment roles that we use in order to launch our CloudFormation into the accounts has enough permissions and is different um, from the role that the user uses to use the CLI and access the console, because these are two different things. And the user gets permission to deploy to an environment, and then it's the deploy role that does the job and not the user's own credentials. So we are moving towards code commit from Gerrit. This is a move that we will do in 2019. This is where we will be improving the correlation between push rights and deploy rights. Currently, we don't really have that correlation set up. Our tools secure the process and that everything goes through in a secure way, but they do not secure the quality. That's up to the developers to secure. So let's take a look at the continuous deployment process, how we want it to look, and how it actually looks in the simplistic service. So we do our build and we do our test. In test, we run our unit tests. This verifies the application to a certain level. Then we launch into QA. And here we want to launch to test the gap between what the unit tests pick up and what you can test deployed. The gap there is really about API gateway to the Lambda, that configuration and all that fits together. So we deploy into that environment, and then we verify. And this is where we want to have a canary deployment, small set of traffic, gets hit, and then if it's not okay, it gets rolled back. If it is for us to verify, it scales up, new code runs fully, it still works. Then we go ahead and launch to prod, do the same thing, verify in a small set. If not okay, roll it back, or else we're done. That's how we want our process to look. So let's take a look at our testing of our application and how we do that. Basically, we have our Lambda, we have the handler, we have our data access implementation, and this is a simple CRUD application. So that's basically what it does. It takes the request, the Lambda figures out what it does, and then the DAO does the job. So what we want to do is we want to mock the database and use an in-memory database, and then we want to test the DAOs and the handlers in the unit tests, and then we want to ignore testing the REST API, and we do that in the deployed Canary releases. So if we look at how we do mocking, it's amazingly simple in using Python. We use a library called Moto, which is a mock of Boto, which is the SDK for Python. You basically just say annotate mock DynamoDB2, and you have, for that unit test in your runtime, you have a DynamoDB. So anything that you do with Boto that is SDK call is a DynamoDB behind it. So we create our mock tables. We define those using both of three and the DynamoDB client. We create a table and we use that in our tests. And so we basically have that as a utility method in our test-based class. Create the table and inject it into our entity DAO, and then we test the entity DAO against the mocked database. Super simple and very effective. And it's kind of nice because the tests really get short and nice. And then we test the handler on its own. We mock the entity DAO. We inject it and say what it should return with this test. We call the handler, it returns, and we validate, and it behaves as expected. Then we also do integration tests here in where we call the handler and we mock the database below the DAO. So we get the entire flow from the handler through the DAO to the mock database. So now we can confidently say that we that we have tested our Lambda really well. We have the handler, we have DAO, everything that is tested. We have tested our queries towards our DynamoDB, and so we know that the queries work and that the DynamoDB is correctly configured for them. But we have done that on tables created in the setup and not with CloudFormation that will be deployed later. So we still have a gap because we have a double definition between our table in the test and our table in what we're actually launching. So we know that this is a gap, and we know that the integration between the REST API and the handler is not tested. But it's okay. We have our QA environment where we can deploy the application, run tests, and we know if it fails, it's in either of these two areas. So we do one more thing before we actually launch. We do sonar static scanning as well, so that we get nice information about code coverage and code quality and code complexity, and also about any possible vulnerabilities. Let's talk a little bit about Canary deployment and how that is done in a good way. So in order to do a Canary deployment, we need something that tells us if the application is working or not. And in order to have alarms, we need traffic. And we need quite a lot of it, because if you get one request a minute and you want to have a Canary pattern like it says on this slide, where you have 10% of the load for 5 minutes, and if that's okay, then switch over. Then within those 5 minutes, you need enough requests to make good alarms. If you have 5 requests, 1 a minute, so 5 requests in 5 minutes, then 2 of those might slide out of that window due to timing issues, and you have 3 successful out of 5, and you don't know if that was good or not. So what I do is I create test bots that generate the traffic and call my REST APIs, and they do it at pretty high load. And the nice thing about having a multi-tenant application is that the test bots have their own tenant. So the data from the test bots is isolated from the data of the consumers. And I can also have a usage plan which is unique to the testbot tenant, so it doesn't consume the resources of the real tenant. So it has its own data isolation, and it has its own request quota on the usage plan on the API, which is very nice. So I drive a load of about 900 requests a minute from my test bots, and I make alarms that are basically, there shouldn't ever be any Lambda errors. On this API, there shouldn't be any 400s or 500s. Sometimes 400s is okay, but it's not on this API. So I have alarms on that. And I also have alarms on number of successful messages, successful requests, and that's the SCRUD count there. And this is important because if you just have on errors, then if your application totally stops working and you're not processing anything, you don't have any alarms that go off. So you need to know your minimum threshold of successful requests that you expect. And what I do is that I define a CloudFormation stack of its own with the alarms. I like to tune my alarms a lot, and I don't like to relaunch my main stacks more than necessary. So I have a stack full of alarms, and I tune them there. And then in my main stack, I do the import of the reference of those alarms. So now that I've deployed to QA, if that 5-minute period of 10% of load passes, then I know my REST API to the Lambda works. I know that the Lambda works because I knew that already, and I know that the integration with the database works. And if something fails, then it's either the top or the bottom part that I need to look into in order to solve that failure. So we go back. I run through. I get into the verify stage. I roll back, and when I say roll back, it rolls it back out of the environment. It doesn't roll it back all the way to Git and revert the change in Git because we obviously need to still investigate it. So it rolls it back to where it's drawn in the picture here, basically. So it rolls it just out of the environment. And if it went okay, it automatically goes ahead and does the prod launch and does the same verification there, because I deploy the same test bots in the prod environment as I do in my QA environment. And the only difference between my QA launch and my prod launch is that there's different endpoints involved for the bots. There is different naming of tenants and so on. So there's those slight differences, and that's what I know I need to look for if I get a rollback on my prod deploy. So in the test, I look at code. In the QA, I look at integration between REST API and between database, and then I look for endpoint and tenant configuration in my prod. So that's the kind of more and more granularity I build on my test pyramid. So if we look at how this is done in Sonic, I basically have my build, test, release, launch steps, and then I have a sequence, which is the auto deploy sequence, and it runs those deploys. And if the first deploy in the sequence failed, the second one won't start. And speed is king when it comes to continuous deployment. It takes about 4 minutes to build, test, and scan the application. Then launching and getting it to a verified OK launch takes about 7 minutes. But as I said, I have a 5-minute canary in there. So it's basically 2 minutes more than the canary time that it takes to get the successful verified. If there's a rollback, the rollback takes 4 minutes, and it's about 1 minute, between 1 and 2 minutes for the error to be recognized by the alarms, and then it's the other 2 minutes as overhead, same as the with the launch. So it's 2 minutes that any possible errors sit in my QA environment or in my prod environment. So the time from push to successfully deployed with very, very high comfort and probability of success in production is done in about 18 minutes. And I think that's a pretty good time, because it's every time spent gives value in this case. So I mean, building and scanning, that provides value. Running the deployed tests in QA, that provides value. So there is really not much time here to shave off. So this is for Lambdas. What about the other stacks where there's no code involved, like DNS or roles or the tables? Let's have a look at that as well. So I do a launch, but I don't have any canary mechanism. So then we'll use a step that is called check in Sonic, which basically does the verification, and if it fails, it will signal the launch as red, and then you need to do a manual rollback. So I need to know and understand my application, what are the parts that I need to do a manual rollback and where I get it automatically. And if I'm launching something that requires a manual rollback, I need to be much more alert and be there and be ready for it. So if I change my database, if I change something in regard to my DNS structure, if I change my roles, then I need to be much more aware. How do I do the check? I basically just, in my Sonic YML, add the check step and what it's supposed to do. In this case, it basically checks alarms for 5-minute duration. It's basically same alarms. It's just an old screenshot here. Actually, I see that with a old export name, but it's the same alarm I had in the other example, and it's a 5-minute duration on that one as well. So it's basically, it does the change, runs for 5 minutes, and if there's no error state on the alarm for 5 minutes, the check step becomes green, and the next launch can start. So here is a view of the environment dashboard for the simplistic service, and as you see, the QA environment and the prod environment, they have the same versions, because I always do continuous deployment. Quite nice. So let's talk a little bit more about monitoring. We talk about alarms, but when something happens, when something breaks and an alarm goes off, like on a launch, I don't want to be sitting on the screen. I want to go away, get my coffee, and then I want my phone to buzz and tell me, you need to go back and fix your stuff. That's what we have PagerDuty for. What we do here is that in my monitoring stack that I was talking about earlier, we have a PagerDuty integration. We do that with a custom resource that creates service for you in PagerDuty, so that you can get your alarms into your phone and you treat them with you get the schedules, escalations, and all those things about the incidents and alarms that PagerDuty gives. It's really nice, and you can link those integrations to PagerDuty in that stack to your alarm, so that any alarm you create there goes straight to PagerDuty. And we also have a endpoint status stack. This one allows us to poll a endpoint on the API to get the status of the service. What it does basically is that you see it here, I do a get, and it responds with a 200 and a service status, operational, and name of the service, and I can return partially down or down as well, and I define that state in my Lambda handler behind it. And what I do is that I actually look at alarms in there. So yeah, so here's a CloudFormation which creates PagerDuty service on the simplistic service definition, the custom resource, the configuration for it. Then you see that there's a topic created. That's the one that is integrated with the PagerDuty. and then you have the lambda errors behind it that reference the simplistic service topic, and by sending the alarms to the topic, they end up in PagerDuty. And here you see in PagerDuty how it looks, and alarms will pop up here for the simplistic service. And I don't have any alarms at the moment, so there's none to show. In our changelog, we can see when things were launched into an environment. It's really useful if you get an alarm to be able to to go and see if something has changed and what versions it was that it went to and from, because the environment view just shows the current state. So here's your changelog of launches into the environments. Another great thing for is visibility, and X-ray provides fantastic visibility in your application. Here is a trace of what my current endpoint does, and it's basically when I hit the endpoint, it does either create an entity or create a relation, and it goes to Lambda, then it goes into the function. The function itself gets the role which it uses to access the database, so that's the SDS call there, and then it does the calls to the database to either do get data or put data. And here you see the average response times and the number of requests that are running on the application. So average response times from a database is about 8 to 9 milliseconds, which is pretty nice. I see that the SDS calls to assume the role, that takes about 345 milliseconds, which is quite a lot, and I don't want to do that often. And you see that I don't, because I cache that in my function. So I cache my session for about an hour before I renew it. So that's why it's so few requests. So it's really useful. You can also go in and look at a single trace to see where your time goes. It looks something like this. You get it split up from the API all the way to the database where the time is consumed. And I mean, obviously you want logging. There's this is a view of Insight. I mean, our lambdas automatically log to our to CloudWatch. Insight is a new tool. It's not really there yet. So I prefer to get my logs into either our central config solution or into somewhere else. But for QA purposes and for a reference implementation, Insight is good enough. Metrics, and you get a ton of default matrices with API gateway, Lambda, and DynamoDB. It covers a lot of things, and you should explore those. The visualization is not great in CloudWatch, so using a dashboarding tool is a good thing, but it's there out of the box, so start using it. So here we are now. We have done our made sure that our continuous deployment is high quality, fast, and secure. We have our application security, we have our operational security, and our administrative security. And I think that's actually a good and solid setup for an application that at least gives me a high level of comfort to work with it, to do changes at a high pace where I'm comfortable pushing when when stuff is working locally, and I expect it to go all the way to prod, and then I can do the next task. And that's pretty much how I want to work with an application, and it works really nice. You should take a look at the application. It's there in Overseer. Just go to the dashboard and have a look. And thank you for listening to this series, and I hope it's been valuable to you.